Morning, students. I welcome you all for today's composite materials class. Today, I am going to discuss about what is composite material and I am going to discuss about the classification related to the composite materials. Okay. Hope I think this particular you all of you are getting my voice. So today, I am going to discuss about okay what is the composite material and what are the types of composites. Okay. So mainly the first unit it consists of the different topics like we'll discuss the fundamentals of composites, definition, classification of the composites based on their structure, based on their matrix, okay, based on the reinforcement. Okay, and we'll discuss different advantages, applications of this different types of composites, and also this particular unit also covers the different types of reinforcements like viscous, glass fiber, carbon fiber, aramid fiber, ceramic fiber, and all these whatever different reinforcement are there. I'll discuss the different properties and their different applications. Okay, right. So So what is the composite material? So you know that a composite material is a material formed by combining two or more different materials with different chemical or physical properties. Okay, whenever you are combining these two or more different materials with different chemical or physical properties, so then the such type of material we'll call it as the composite material. Okay. Why we are going to combine these different materials is mainly to improve the like its properties. Okay. Based like we can improve the strength, stiffness, sometimes corrosion resistance, depending upon the requirement. Okay. Based on the what is the type of reinforcement we are going to add to the composite. Okay, the properties may get varied. So what is the composite material is like a composite material is a material formed by combining two or more different materials, so with the different or chemical or physical properties. Okay, so in this composite materials, this composite material mainly consists two components. Okay, I already mentioned that whenever we are combining two or more materials, okay, then it is known as the composite material. So whenever you are mixing two or more materials, you have to see that in that in the two or three materials, one should be the reinforcement, another should be the matrix. Okay, these are the two main components of the composite material. Okay, whenever you are mixing two or more different materials of different physical or chemical properties, okay, you have to see that these materials should belong, at least one material should belong to reinforcement and another material should belong to the matrix. Okay, so in that the reinforcement, why we have to take the reinforcement, because to increase the like its strength and stiffness, to make the material is strong and stiff, that to make that we are going to add these reinforcements. Okay, so whenever like this particular reinforcement phase is the like dispersal phase that provides strength, stiffness, and other different mechanical properties. Okay? They not only provides the strength and stiffness, so based on the requirement and based on the what type of reinforcement you are going to add, okay, whatever the thing you are going to choose, that may like other properties also may get added. Okay, maybe it's toughness, or maybe it's malleability property, or sometimes thermal conductivity, all these different properties may you may get increased depending upon the requirements. Okay, so that is the main no, why we are going to add the reinforcement mainly because when compared to the base material, you have to make the composite such a way that you should improve the different mechanical properties like strength, stiffness, okay, toughness, or this hardness, or other different properties. Okay, examples of these fibers. Okay, there we can add reinforcement in the form of like fiber or in the form of particulate also. Okay, some examples are like carbon fiber, fiberglass fiber, or wood pulp. All these are the different reinforcements. Okay, sometimes you are adding the reinforcement like in the form of particulate or powder form. You can add like silicon carbide SiC, that is silicon carbide in the powder form, or aluminum oxide in the powder form. Like that, you can add fibers or you can add the like powder form of material as the reinforcement. Okay, and another ingredient, that is another component of the composite material is the matrix. Okay, so what is the main property why we have to use this matrix is mainly this matrix. Okay, which will holds the reinforcement. So such a way that all this load across it mainly distributes the the even distribution of the load across the reinforcement. For that purpose, we are going to use as the like matrix. So mainly it give the this particular matrix material makes the reinforcement together. Okay, all they have to bond and they have to give one shape. For that purpose, we have to use the matrix. And like during the application, the reinforce whenever this to distribute the load across the reinforcement, that makes the even distribution or other different possibilities will be made by this particular matrix. So different types of matrix materials we can use, like we can use the polymers, we can use the matrix, like as we can use the metal matrix, or we can use the ceramics. We can use plastic materials like epoxy. These are the polymer matrix materials. Okay, and you can use the like metals. You can use like aluminum, or you can use the magnesium. We can use the copper, or different types of metals also. We can add as the matrix material. We will discuss later in detail about those different types of matrix based on the material. So mainly the composite material. Mainly it have the two components. One is the reinforcement, another one is the matrix. Okay, mainly to improve the properties of the base material, we have to add the reinforcement, so which will improve the different properties like strength, stiffness, or other different mechanical properties, sometimes thermal conductivity or corrosion resistance. All these different things based on the consumer's requirement can add the different types of reinforcement. Okay, and matrix main thing is to hold and give one proper shape to the material. That is the main purpose of this particular matrix material. Okay, so next topic is the classification of composites based on the matrix. Okay, mainly the composite material, already mentioned that the composite material mainly consists of two different components or ingredients. One is the like like reinforcement, another one is the matrix. So in that matrix, okay, we can use different types of matrix. Based on that, they are classified as the polymer matrix composites, metal matrix composites, ceramic matrix composites, and carbon carbon composites. Okay, mainly you can use if you are using the polymer as the matrix material, okay, then it is known as the polymer matrix composites. So we can use different types of polymers. Okay, one of the generally used polymer is the epoxy, the mostly used due to the less cost of the particular matrix material. And another type of matrix material is the metal matrix composites, where we are going to use different metals like aluminum, magnesium, titanium as the matrix material. So, based on the requirement, can choose the different types of metals. So, if you are using the metals as the matrix materials, then the composites are known as the metal matrix composites. Okay. So, next composite is the ceramic matrix composite. So, when if you are using the ceramic materials as the matrix, okay, ceramic materials as the matrix, then they are known as the ceramic matrix composite, mainly for high temperature environment conditions. Then such type of applications, we can use this particular ceramic matrix composites. Okay, and another one is you can use carbon as the matrix as well as the carbon as the reinforcement. Such type of composites are called as the carbon-carbon composites. Okay, carbon, we can use the carbon as the matrix material, and at the same time we can use matrix also. We can use as the carbon as the matrix material, carbon as the matrix as well as the reinforcement material. Such a type of composites, they are known as the carbon carbon composites. We can use both carbon as matrix as well as we can use a carbon as the reinforcement material. Then such type of things are known as the carbon-carbon composites. Mainly they are used for different these carbon-carbon composites are mainly used for high temperature applications, mainly for aerospace and automotive industries to make the different components of aerospace and like automobile components. Then they are going to use this carbon-carbon composites. Okay, and another classification, okay, of this particular composites is based on the structure. Okay, one is already discussed that based on the matrix, the composites are classified as polymer matrix composites, metal matrix composites, ceramic matrix composites, carbon-carbon composites. So another classification is based on the structure. These composites are classified as laminar composites, particulate composites, and another one is the fiber reinforced composites. So in the laminar composites, mainly where we are going to applying different layers of material one over the other. Such type of things will call it as the laminar composites. Mainly these laminar composites made by stacking layers of materials. Uh, then such type of things comes under the laminar composites. We are going to add one layer over the other. So then such type of composite materials are comes under the laminar composites, and another one is comes under the particulate composites. So here we are going to use small particles. So these particles are we are going to distributing into the matrix material. Then they are known as the particulate composite. Whenever you are using some small particle, they are going to you may dispersing means the latter will discuss in detail. Like there are different techniques like in the dispersion technique. Maybe you can use stir casting or Swiss casting technique. So these are the that is about the particulate compounds. Mainly we are going to distribute small particles in the matrix. Then such a type of composites are known as the particulate composites. And other next one is fiber reinforced composites, where we are going to use some continuous or discontinuous fibers. We are going to adding or embedded in the matrix. Then they are known as the fiber reinforced composites. So we are going to adding continuous or discontinuous fibers into the matrix. Then they are known as the fiber reinforced composites. So this is the one other classification of the composites based on the structure. Based on the structure, they may be classified as the laminar composites or particulate composites or fiber reinforced composites. Okay. Next classification of the composites is the based on the reinforcement. Okay. So these composites composite material. So we can use the reinforcement. What type of reinforcement you are using? Based on that, they are classified as the fiber reinforced composites and particle reinforced composites. One is the fiber reinforced composite, another one is the particle reinforced composites. So here you can see that this composite material, mainly what type of reinforcement we are using. One is the fiber reinforced composite, another one is the particle reinforced composites. So these are fiber reinforced composites, again classified as single layer composites. Okay, and these single layer composites are again classified as the continuous fiber reinforced composite and discontinuous fiber reinforced composites. This fiber reinforced composite, one more variation is multi-layered composite. The multi-layer composites again classified as the laminates and hybrids. And these continuous fiber reinforced composites are again subclassified as the unidirectional reinforcement and bidirectional reinforcement. And these particular discontinuous fiber reinforced composites are classified as random oriented composites and preferred orientation composites. Mainly, these composites material again I am repeating based on the like type of reinforcement, whether you are using the fiber or whether using the particles. If you are using the fibers, the fiber reinforced composites are classified as subclassified as again single layer composites and multi-layered composites. These single layer composites are again subclassified as continuous fiber reinforced composites and discontinuous fiber reinforced composites. Multi-layered composites are again subclassified as laminates and hybrids. The continuous fiber reinforced composites are again subclassified as unidirectional reinforcement composites and bidirectional reinforcement composites. Again, this continuous fiber reinforced composites are subclassified as random oriented composites and preferred orientation discontinuous fiber reinforced composites. That's it for today, my dear students. Tomorrow and next class, I'll discuss in detail about this particular uh, how all these different types of reinforcement and their different things I'll discuss in the next class. Today I just gone through the what is the composite material, okay, and what are the main components. They mainly this particular composite material consists of two components. One is the matrix, another one is the reinforcement, and after that, based on the uh, type of how the class composites are classified based on the type of matrix. They are what is the polymer composite, what is the matrix composite, and what is the ceramic matrix composite, and what is the carbon composite. And after that, I discuss the based on the structure. The mainly these composites are classified as laminar composites, particulate composites, and fiber reinforced composite. And after that, I just one more variation of this composite classification is that based on the reinforcement, they are classified as the fiber reinforced composites and particle reinforced composites. Okay, that's it for today. That's it for today. Thank you. Thank you.